Hey, it's Merrick. On February 4th, 2020, Chrome started enforcing the SameSite attribute for cookies. Now, it just so happens that as I'm recording this, we're in the middle of the COVID-19 pandemic. So as of April 3rd, they've actually rolled back this update on stable versions of Chrome. However, they will be enforcing it again in the near future, so everything will still apply. And depending on when you're watching this, it may already be rolled out. So let's talk about why they're enforcing the SameSite attribute and what it means for you. Let's go over a few key aspects of cookies. First, they can only be read by the domain that they're set for. So if website.a.com sets a cookie, only website A will be able to access it. And secondly, whenever requests are made to that domain from your machine, that cookie will be passed along in the header automatically. So every single request will have that cookie sent along with it. It's this second aspect that poses a security vulnerability, because requests aren't always made intentionally by you. When someone takes advantage of this vulnerability, it's called a CSRF attack, or cross-site request forgery attack. Let me just give you a quick example. Let's say website.a.com stores a cookie when you log in. So if a user has this cookie set, they're considered to be logged in. Now, whenever you visit pages on website.a.com, your requests automatically send that cookie back to them. And since they know you're logged in, you can interact with the site, make profile changes, etc. You have full access to play around with your account. Remember, cookies get sent automatically in requests to the domain they're set for. So now, say you're visiting attackerwebsite.com, and there's a form there that asks you for your email if you want a discount code for Amazon. But instead of a discount code, it makes a request to website.a.com. Since the login cookie automatically gets sent in the request, website A thinks it's a legitimate request and changes the email and password in your profile. Notice how the attack is being made cross-site, so from one site to another, specifically attackerwebsite.com to website.a.com. Now, there's many ways for website A to prevent this type of attack, but in this example, let's say website A completely dropped the ball. So since you have that login cookie set on website A and they have no security in place, any requests made to it, even if it's from a third-party website, will seem legit. So hopefully website.a.com isn't your banking website, otherwise attackers would be able to send money to themselves, or change your account information, or your address. Okay, so that lays out the big vulnerability of cookies. Now, there's a difference between the way that cookies are being sent during a CSRF attack and during a normal user-initiated request to a website. In the normal case, you're visiting website.a.com and you click on a link or submit a form. Since you're actually on website A, the cookies that are automatically sent in those requests are being used in what's called a first-party context. In the case of a CSRF attack, website B is secretly making a cross-site request to website.a.com, hoping that they can take advantage of the fact that you have a specific cookie set. In this case, since the originating website isn't the one making the request, the cookies are being used in a third-party context. Being able to distinguish between first-party and third-party cookies is what allows the SameSite attribute to protect you from CSRF attacks. So by enforcing this attribute, Chrome is essentially creating a filter through which cookies are allowed to be sent automatically. Depending on the type of request from a third party, Chrome will filter out or deny certain cookies based on their SameSite attribute. The three possible values are strict, lax, and none. The strict setting is the most secure. If a request contains a third-party cookie set to strict, it won't make it through. It'll be blocked no matter the type of request. This includes links from anchor tags. The lax setting is semi-secure. It'll allow cookies through top-level navigation, like anchor tags or GET requests, but it'll block other ones, like POST requests. I'll go over this with some examples later. And finally, the none setting is the least secure. It'll allow third-party cookies to be sent no matter the type of request, but it has to be used alongside the secure attribute, meaning it has to be made through a secure HTTPS connection. Okay, so let's set a bunch of cookies with each of the different SameSite values. So I'll set a strict cookie, one lax cookie, one none cookie, and one cookie with no SameSite value at all. So as you can see, we have one of each type. You can see them here. And for now, like I said, Chrome is not enforcing this, so the unset SameSite cookie will be treated as none. But in the future, it's going to be treated as lax. So just keep that in mind. So we have all these cookies set on the localhost domain. And now I have a different domain, merrickchun.com, where I will be making a bunch of different cross-site requests, and we'll see which cookies actually get sent in the header of these requests. So let's open up a network tab here and see what's going on. So this first test will be for a regular link. So this is just an anchor tag that links out to localhost. So let's see what happens. So as you see, merrickchun.com redirected to localhost, which is where our cookies are. And if we look at the actual request, we see right here, the lax cookie, the none cookie, and the unset cookie got sent, but the strict cookie did not get sent because that blocks all third-party requests. So a regular link will allow lax cookies to be sent in the header. Next, let's clear this out first. Let's do a normal GET request that also does a top-level navigation change. So we'll just type in some gibberish here, and when we hit this, we're going to be redirected to localhost because it's a GET request to localhost. And let's see what happens. So we're now on localhost. It was a GET request, and we can see in the request headers that lax again was sent as well as none, but strict is not here. So those are pretty much the two cases where the lax cookies will make it through. So top level navigation changes on links and safe GET requests. Next, let's try a link to a page still within merrickchun.com, but this page will load an iframe which will make a request to localhost. So let's see what happens. All right, so as you see, we have the iframe here, which loads localhost where the cookies are. And if we look into the details of that request, we'll see only the none cookies were sent here. So even lax was blocked, and obviously strict. Next, we'll try another link to a page within merrickchun.com, but in this case, instead of doing an iframe request, it's going to do a request through an image. So the source of the image is localhost, and let's see what happens. Clear this out first. All right, so here's the request from our image. And again, only the cookies with SameSite none actually get sent in this request. Lax and strict are both blocked. All right, and here we will do an AJAX GET request. So this is sort of an unsafe GET request that happens in the background. So you won't see anything happening on your screen. This request is happening in the background. So here is the request, and look at that. Only cookies with SameSite none will be allowed to be sent in this type of request. So even though it's also a GET request, because it's being done, kind of in the background, it's blocking all cookies except for SameSite none cookies. And then next, we will try a regular post request, which will do a top-level navigation change, but because it's a post request, well, let's see what happens. In the request header, only none get sent. Lax and strict are both blocked, even though there was a top-level navigation change. And finally, I'm sure you can guess what's going to happen, but we'll do an AJAX post request. So this happens in the background. And obviously, only the SameSite none cookie gets sent. So just to reiterate, cookies set with a strict setting will only be able to be used in a first-party context. Cookies with the lax setting will be able to make it through on top-level navigation like links and GET requests. And cookies with the none setting will also make it through cross-site requests, as long as they also have the secure attribute. So when should you use which setting? Well, that really depends on what the cookie is being used for. So if the cookie is for authentication and it needs to be secured, and other websites don't need to embed pages from your website on theirs, then you can use strict or lax. Because lax will still protect you from post requests, and if your site is designed well, you're not going to use GET requests to modify any data. So this will allow people to click on links to your website and still be logged in if they were logged in previously. Now, if you're using the cookie for tracking purposes, then you may want to use the none setting, because that's the only way that all different types of requests will make it through from third-party domains. Now, keep in mind that the SameSite setting is only as secure as the browser being used. If the browser doesn't support or enforce the SameSite settings on cookies, then it's not really going to do much. So this is more of something that you should use alongside other security techniques to prevent cross-site scripting. And that's pretty much it. So hopefully you learned a little bit about what SameSite cookies are and how you can use them to better secure your site, or to make sure that you can still track users of your website across the web. If you enjoyed this video, then please give it a like, and if you want more content like this, you can subscribe.